Okay, I know what you're thinking. Identities, it can't get any worse. Well, you know what? The more formulas you know, the easier identities become because you have more playing pieces. Things that you had to work hard for become easier. So I picked out one that is what I call a very highly computational identity. That's example one. This is like a computational identity. And then you'll see my second one. But what they have in common is this. They have a syncos cosine and a couscous look to them. So, when I see the first part, I say to myself, you know what? Looks like I should do some expanding. And that's exactly what you want to do. When you guys look at the problems on page 222, 61 to 65, you'll notice that if you apply the syncos cosine and the couscous formula, it usually just falls into place. Sometimes you have to do a little bit of sneakiness, but not too much. So let's begin. The very first part, I'm going to do this all left hand, by the way. This is a left hand problem. So I'm going to say sine of pi over 6th cosine x plus cosine of pi over 6th sine of x. What am I going to do with that? I'm going to be adding it to, now I'm going to do couscous. So cosine pi over 3 cosine x minus sine pi over 3 sine x. This whole thing is left hand. What am I shooting for? That. So I don't have that much room. I got to write where I can. But the thing is now, I'm going to think of my bow tie. I'm going to say, wait, pi over 6th. If I had a pi 6th angle, I could do 1, rad 3, and 2. And the other angle I need over here is going to be a pi over 3 angle. And that's just 1, rad 3, and 2. And I'm going to go get some stuff. So where I say sine of pi 6ths, that's the same as 1/2. What's it going to be? 1/2 of cosine x. I'm just working right here, guys. Right here. This is my stuff. Plus, now let's do the cosine of pi over 6. Well, that's just rad 3 over 2 times the sine of x. Since I expanded the sign out, that's what I got. Plus, now let's go get the other side. So plus, here, I'm going to start working here. What is the cosine of pi over 3? Well, it's just 1/2 times cosine x. Minus, so I'm going to go get sine of pi over 3. The sine of pi over 3 is rad 3 over 2 times sine x. Now, I don't know if you guys noticed this, but if I don't know my formulas and I have sign errors anywhere in my problem, it is going to kill me. But if I have my formulas down right, look at what happens here. One of these knocks out one of those. And what do I have left? I have 1/2 cosine x. Here's my other guy over here. Plus another 1/2 cosine x. Well, 1/2 plus 1/2 is 2/2, or 1 entire cosine x. In case I lost you there, let me do this. 1/2 plus 1/2 is 2/2 of cosine x. Well, that's just cosine x. Hey, wait a minute. That's what they wanted me to find, and I found it. So when you think of doing these identities, don't panic so much, because what are they based on? They're based on the fact that you now know something more. You know how to expand all this stuff. And that's what it takes. And you also have to know your reference triangles. Man, that's why I spent all that time doing that. And then I clued you in on this bow tie trick and all this stuff. I'm trying to make your life a little bit easier. But, as you can see, the left-hand side equals the right-hand side. That is what I call an identity that requires me to know my computational trig. Now, you're going to find one just like that. I think it's 63. But, you know, when in doubt, use the formula to expand it out. Ooh, and that was a fresh rhyme. Here's my next one. And I wanted to do this one because it looks a little bit different. Also, I wanted to give you a warning, because somebody always tries to do this to me. Okay? This is not this. It's not. They're not the same thing. Don't think they are. Okay? Not the same thing. This is a formula. This turns out to be all kinds of stuff. Whoop, tam. Tan. This turns out to be this. That is definitely not what that says. So please do not jump the gun on stuff. Just because you are used to seeing tangent A plus B doesn't mean it's the same as tangent A plus tangent B. If it was, I'd tell you, but it ain't. So here we go. Let's go back. We're going to get rid of all the red, because I think I can do it pretty quickly if I just keep tapping that thing. I'm just backing it all out. But please don't think those are the same thing. Let's get a black pen. Let's get to work. I'm going to do this guy on the left-hand side. Here we go. What does it look like? It looks like I have a sign expansion in the numerator. So I'm going to sin cosine it. I'm going to go sine A, cosine B, plus cosine A, sine B. Now the whole thing is over cosine A, cosine B. Now this is where you got to remember some of your most basic, simple math. If I have this guy right here, and I have this guy right here, I can split it and say it's the same as this fraction plus this fraction. Oh my gosh. You see what I did there? I just took it and I split it into two denominators. I'm working left hand. I forgot to write that down. But take a look at what I have. See this first fraction? I can cancel those. They match. What do I end up with? Sine A over cosine A. You seeing something here? Cha-ching! I end up with sine B over cosine B. Well, the last time I checked, this was the same thing as tangent A. And this was the last time I checked, this thing was the same as tangent B. And that's what this side equals. They are equivalent statements. Yes, they are. So the point of the story here is, when in doubt, expand it out and then look for the goodness that could be yours. The problems I gave you, 61 to 65, are just really good illustrations of that. Now, just in case you got time on your hands and you're bored, number 67 is a good one. But the trick with number 67, it says la 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 on this side equals, and you don't have to do this, but some of you guys are geeky and you might want to try it. Heck, I was a supreme math geek. Anyway, That's what the right-hand side says. Here's the secret. Over here, you'll see it. It's really clear. Expand that baby out. Expand it out. And you might look at it and go, what am I going to do with that? The trick is, this is a bother. If you do both sides, you get it to work. But the trick with this is, once again, don't be fooled. Tangent x minus tangent y does not equal tangent x minus y. Don't be fooled. But you know what? You're going to see a whole bunch of sine and cosine over here. So my hint is double fraction town. This is only if you want to try this one. I don't know. Sometimes I like to play with identities. I think they're fun puzzles. That's how destroyed my brain is. So, double fraction, bust that double fraction, and you should find your salvation. That's only if you want to try it, number 67. But most of the situation you're going to go through here, practice expanding your formulas. Okay, that's the last lesson for section 5.4. Hallelujah. Bye-bye.